Now we come to describe the density and specific gravity, the two terms that we use in our everyday life. Every now and then we talk of them. The density is defined as mass per unit volume of any fluid or any body, that any mass that is under consideration. And since we are talking about only the fluids, therefore we limit our discussions to these parameters for fluids only. Density normally is denoted by rho, and it is calculated by computing the ratio of mass over the volume. So, and it is written as rho is equal to mass over total volume, m over v. So kilogram per meter if we are using the CGM system or metric system, but it will be different units if we are using British system. The reciprocal of the density is a specific volume. So 1 over rho is specific gravity, which is defined as volume per unit mass. For a differential volume element of mass dm and volume dv, density can be expressed as rho equal to dm over dv. Remember, when we are considering small deviation, small distance, or change in time or change in distance, then if distance is denoted by x, we denote a small change in distance as dx. Similarly, for time, a small change in time is denoted by dt. And likewise here, a small change in mass and volume will be denoted by dm and dv respectively, and accordingly the rho, corresponding rho will be rho is equal to dm over dv. We can just as well denote it as d rho also to indicate that it's a small change in the density. The density of a substance in general depends on temperature and pressure. So we very much know, this is a common knowledge. The density of most gases is proportional to pressure and is inversely proportional to temperature, which means if we decrease the temperature, the density increases, and if we increase the temperature, the density decreases. Again, a very familiar scene for us. If we boil something, if we heat up something, then, or the gases itself, then the gases expand, and what happens is that they become rarefied at their volume expands. So therefore the density at a particular point will be reducing at a higher temperature compared to the normal temperature. Liquids and solids, on the other hand, are essentially incompressible substances, and the variation of their density pressure is usually negligible. So in liquids, it's a different scenario, but in gases, there is a significant change that we can see. And to give you an example, at 20 degrees centigrade, which is considered to be standard temperature for this kind of measurement, the density of water changes from 998 kilogram per meter per cubic meter at 1 atmospheric pressure to 1003 kilogram per meter cube at 100 atmospheric pressure, which is a change of density with pressure, and that is usually negligible. It's a small change and that can be ignored. But at 20, this change is considered to be about 5%, and we can really ignore it, 0.05%, which can really be ignored, and it's a small change. The density of liquids and solids depend more strongly on temperature than it does on pressure. At 1 atmospheric pressure, for example, the density of water changes from 998 kilogram per meter cube at 20 degrees centigrade to 975 kilogram per cubic meter at 75 degrees, a change of 2.3%, which can still be neglected in many engineering analysis. In most of the analysis, we can also ignore considering change. Then it is called specific gravity or relative density, and that is defined as the ratio of density of a substance to the density of some standard substance. At a specified temperature of water, for example, at 4 degrees centigrade, which is rho of water. H2O is a formula that we use in chemistry to represent water. So rho of water, that is density of water, is 1000 kilogram per metric cube at 4 degrees temperature, considered as the normal or the representative density of water. And the specific gravity will be correspondingly defined as rho over rho of water. So specific gravity, if we have to calculate, as I have said, that these are calculated by calculating the density with respect to the density of a standard liquid or fluid. And water is considered to be a standard liquid. So if we want to determine specific gravity of many elements, it is calculated as rho divided by density divided by density of water at a given temperature.